Unix-like operating systems are by nature multi-users, which means that more than one user can operate the computer at the same time. For example, if the computer is attached to the network or the internet, remote users can log in via Secure Shell and operate the computer. In order to make this practical, a method had to be devised to protect the users from each other, as after all, we would not want the actions of one user to crash the computer, nor would we allow one user to interfere with the files belonging to another user. So in this lecture, we will see how we can change the access rights of files and directories, starting with a little bit of theory. If you remember, in the lecture about links, I briefly introduced you to the file permissions using the ls command that was displaying these permissions in the symbolic notation. An alternate and shorter way to the symbolic notation for representing permissions is to use what's called the octal notation, which consists of 3 digits representing the permissions of the owner, the group, and the others. Here's a few examples on what symbolic permissions would look like using the octal notation. So let's now take a minute to break this notation down. As you know, an individual permission is either granted or not granted, which can be easily translated into the bits 1 and 0 in binary, where a read-only would be 100, write-only would be 010, execute-only 001, and finally read, write, and execute would be translated to 111. Now, the first step to go from binary to octal is to translate binary to decimal. To do this, we add each bit multiplied by 2 to the power of its position. For example, considering the read-only permission from right to left, the first bit is to be converted to 0 multiplied by 2 to the power of 0, the second one to 0 multiplied by 2 to the power of 1, and the third one to 1 multiplied by 2 to the power of 2. Once we've done that, we then add up all these numbers, which in this case gives us the result of 4. Following this logic, we would then have 4 for the read permission, 2 for the write permission, and 1 for the execute permission. So by extension, read and write would be 4 plus 2, which is equal to 6. Read and execute would be 4 plus 1, which is equal to 5. And write and execute will be 2 plus 1, which is equal to 3. Now, if we represent each of the 3 as a single digit, we end up with a pretty convenient way of expressing permission settings. So let's now apply what we've just seen. The command used to change file permissions is called chmod, which stands for change mode. If we wanted, for example, to set the read and write permissions for the owner of this file only, we would run the following command. If instead we wanted to give the read permissions to everyone, including the owner of the file, the group, and the others, we could write this command. Note that the chmod command can also be used to change the access rights of directories, but that the meaning of the R, W, and X attributes is a little different. R allows the content of the directory to be listed if the X attribute is also set. W allows files within the directory to be created, deleted, or renamed if the X attribute is also set, and X allows a directory to be entered using the cd command. For example, the 700 permission means that only the owner of the directory has full access to it and no one else, while the 755 permission means that the owner has full access and that the group and the others may list what's contained in it, but cannot create files nor delete them. As you can see, changing permissions for files and directories is quite easy, as all you have to remember really is that read is 4, write is 2, and execute is 1. In the following lectures, we'll learn how to execute commands as the super user and also how to create new user and groups of users.